Alright, so we are back with precalculus simplifying rational expressions. This is the back portion of the partial fraction decomp worksheet. This is the back section. So we're going to go through a number of these together just so you can get the general grasp of these problems. So this is a number 1. We're going to be starting with number 1. Let me actually make my marker thicker. Okay, there we go. So we have number 1, starting with number 1, 15 over 15p plus, plus 30. Okay, whoa. But anyway, so we just want to factor this out, and that is going to look like we have 15 over 15 times p plus 2. 15 times p plus 2. So now we have 15 over 15 times p plus 2. And now these two just cancel out. And because this p plus 2 is on the bottom, our final answer would be 1 over p plus 2. On the back side, notice it also says state any excluded values. Any excluded values. An excluded value is something that would make the equation, or expression rather, like not really work. That's the best way I can describe it. It's like, for example, a fraction. In a fraction, the denominator, let me write it down. The denominator cannot equal 0 because you cannot divide by 0. So what could p be that would make the denominator 0? Well, -2, because -2 plus 2 equals 0. So for our excluded values, p cannot be -2, and we're going to include that in our final answer. Now onto our next problem. We have 10n squared minus 35n over 40n squared. This is number 2 on the worksheet. So the top part would seem pretty simple, right? So we just factor out the 5. So we get 5n times 2n minus 7. Simple enough. But what about this bottom part? Well, basically what you want to do is look for a common factor. Because I suppose if you really wanted to, you could do 10 times 4. Or like 10n times 4n. But I don't know why you would do that. But the point is, we're looking for a common factor, right? And so we have this 5 right here. And can we use 5 to get to 40? Yes, we can, because 5 times 8 is equal to 40. So what we could do is do 5n times 8n. So then these 5n's cross out, leaving us with an answer of 2n minus 7. Make that n better. 2n minus 7 over 8n. And then our excluded value here, our excluded value would just be 0, because only 0 can make the 8 0, because it's multiplying it. You could make it 8 times -3, 8 times 37, 8 times -700, whatever. It's still going to be valid, but 8 times 0, that's going to equal 0, because multiplying a number by 0 always equals 0. So we have our final answers right here, and n cannot equal 0. Now on to our third example. We have 21a plus 28 over 49. Now you'll notice that all of these numbers are divisible by 7 right off the bat. So that is very nice for us, because we can immediately just go to 7 times 3a plus 4 over 7 times 7. These 7's cross out, leaving us with an answer of 3a plus 4 over 7. So you might be asking, what do we do with the excluded values? Well, in this case, a can literally be anything at once. There's nothing, excuse me, the variable is not here on the denominator to affect it. And a can literally be any number up here on the numerator, and it wouldn't matter. So in this case, we would just put a is equal to all real numbers, and the sign for all real numbers looks like this. So a can be all real numbers. It can be all real numbers. So these are our final answers for number 3. Getting into a bit more complicated stuff, we have this amalgamation, which looks scary at first, but let's break it down. So we have this division sign, which means that we can keep, change, flip. So you keep this the way it is, you change this to a multiplication sign, and then you flip the numerator and excuse me, the denominator. So I'm going to cut to what that looks like right now. So now we have this. This is what it looks like after being keep, change, flipped. And now what we're going to have to do is factor each and every one of these, which thankfully these are easy to do, and I'm going to cut again to what that looks like. So this is what everything looks like after being factored out. And I just made it one big fraction because since they're multiplying, we can do that, and it makes it easier for the eyes. And now we get to cross out a whole bunch of these. So we can cross out these m plus 7s, we can cross out these m minus 1s, and we can cross out these m minus 3s. So we're left with just m minus 7 over m minus 6. So that would be our simplified rational expression. And as for the excluded values, basically all we need to do is, again, look at the denominator, and all we need to do is look at each of these individual bodies and see what could m equal to make it not work. And we're just looking at these individually. So if we're looking at m minus 6, for example, the excluded value would be 6. And that's one of the excluded values. We don't care about the rest of these right now. We're just looking at that as an individual. And m cannot be 6 because 6 minus 6 is 0, and it can't be the denominator. So then we're going to move on to the next one, like m minus 3. So m cannot be 3. Let me write a better 3. And then for m plus 7, m cannot equal negative 7. And then as for m minus 1, m cannot equal 1. And then these would all be the excluded values, and those are the only 4 excluded values that there are. So our answer would be m minus 7 over m minus 6, and then our excluded values for m would be 6, 3, negative 7, and 1. And now we're on to this one. This is number 7 of the worksheet, and this was one of the ones that threw me off. These addition and subtraction ones are really hard because remember, this is addition and subtraction, which means we can't use the same method of that we did for multiplication and division. We are adding and subtracting fractions here, which means that we have to make the denominators the same. We have to do that. So first of all, let's just simplify 2x minus 4. Okay, so 2x minus 4 is equal to 2 times x minus 2. Let's just keep it like that. So now I'm just going to erase this and make it so that it agrees with our thing. So 2 times x minus 2. So now we have to make the denominators the same. So we have to multiply these to the numerator and the denominator, and we have to multiply this to the numerator and the denominator. So now we have this whole thing, and now the best thing to do is to multiply these things out. So let's do that now. So now we are here, and we have the 6x squared minus 12x because we do 3x times 2, which is 6x, and then we would distribute the 6x to this x and this negative 2. So we're here, and now since the denominators are the same, now we can smoothly, ever so smoothly transition into just subtracting these values right here. So then, after subtracting, we will get 6x minus 17x plus 25. Notice the plus 25 because this 25 is negative and we're subtracting that negative. And subtracting a negative is the same as adding a positive. So that would be plus 25 right here. And then this would be over our same denominator, 2 times x minus 2 times x minus 5. And this would be our final answer. This would be the simplified expression. And then as for our excluded values, we're only worried about these two bodies because that 2 was just alone. So x cannot equal 2 or 5 because that would make the denominator equal to 0. So these are our final answers, and that I think covers all the bases for simplifying rational expressions. So thanks for watching. I hope this helped you guys, and I'll see you soon. Peace.